Okay, so we're in the last section here, a little bit of a longer section. So here we're supposed to balance and then figure out the net ionic equation. So the first thing I'm going to do is balance this thing. We got one calcium here, we got one calcium there, we got two chlorines there, we got two chlorines here, we got one zinc there, we got one sulfate here, one sulfate here. So guess what? It is already balanced. So that part's easy. Okay, so let's just get to the other stuff then. So calcium chloride is, if you look at the solubility rules, chlorides are soluble, and calcium is not an exception. If you look at sulfates, sulfates are soluble, and zinc is not an exception. Zinc chloride, chlorides are soluble, and zinc is not an exception. And calcium sulfate, sulfates are soluble unless they're attached to calcium, so this is your solid. Okay. Next thing is, let's start writing this out. So Ca2 plus aqueous plus 2Cls minus aqueous plus Zn plus 2. How do you know it's plus 2? Because sulfate is minus 2. So this must be a plus 2. Just double checking that real quick. Sulfate minus 2. Yep, okay. So this is aqueous plus SO4 2 minus, that's aqueous, produces zinc plus 2 aqueous plus 2Cl minuses aqueous plus, okay, now this is a precipitate. It doesn't break apart. That's the whole point, is that it stays solid. All right, so that is the complete ionic equation, but we are supposed to do the net ionic equation. So all we're going to do is we're going to ignore the spectator ions. And if you think about it, this is a spectator ion here, the chlorines, because they appear there and there. The zinc is right there and there. So what happens is really just the calcium 2 plus aqueous plus the sulfate 2 minus aqueous produce calcium sulfate, which is a solid. And that is the net ionic equation. Okay, so here's B. Again, let's balance it out. First things first, we got two ammonias here, so let's put a 2 over here. And notice now that we have two ammonias. We got one carbonate, we got one calcium, two bromides, two. Okay, so this whole thing is balanced now. So now we can get to the work. All right. So ammonia carbonate. So ammonium carbonate. Carbonates are typically insoluble unless they're attached to a type 1 or ammonia. So that's aqueous. Calcium bromide. Bromides are typically soluble unless it's attached to a type 1 or a group 1 metal, and calcium is not. Calcium carbonate. Carbonates are typically insoluble unless they're attached to a group 1, and calcium is not a group 1, so this is solid. And then again, bromides are insoluble, unless they're attached to, and ammonia is not an exception, so they're soluble. So bromides again are soluble, and ammonium is not an exception. So here we go. Now we can start breaking this apart. We got two ammoniums, they're plus 1 charges, those are aqueous, plus a CO3, that's a 2 minus, that's aqueous, plus single calcium, which is a 2 plus, that's aqueous, plus 2 Brs, aqueous. All right, so calcium carbonate is our precipitate, so that is just left like that as a solid form, plus, all right, now we gotta break this apart. 2 NH4 pluses, aqueous, plus 2 Br minuses, aqueous. Again, it's 2 Brs and 2 ammonias. That's why those numbers are there. So that's the complete ionic equation. Let's simplify this to the net ionic equation. So where are the spectator ions? We got ammonia here, we got ammonia there. We got bromines here. And doesn't it make sense that only the ions that form the solid should be the ones left in the ionic equation? So yeah. So here we're going to have Ca2 plus aqueous plus CO3 2 minus aqueous produces calcium carbonate, which is a solid. It does not matter the order that you have those two, but I just switched the order just because I like to put the in the same order as the final thing. All right, so we got one more to go. So here we go. Let's check these out. We got 3 lithiums here. So let's put a 3 right there. Actually, you know what? I remember this one, so I'm just gonna go a different route. I see 3 coppers right here, so I'm gonna put a 3 right here to get 3 coppers. That leaves 6 chlorides, so let's put a 6 right here. Now we got 6 chlorides, 6 lithiums. Let's put a 2 right here to get us our 6 lithiums. We got 2 phosphates, and now we have 2 phosphates. So this is perfectly balanced now. So I'm gonna erase those. And okay, so now we can start. So lithium phosphate. Phosphates are typically insoluble unless they're attached to something like lithium. So they're aqueous. We've covered that one before. All right, copper phosphate. Phosphates are typically insoluble, and copper is not an exception, so that must be our solid. And lithium chloride is definitely aqueous. So now let's break this apart. So we have 2 Li3s, so that's going to be 6 Li pluses, aqueous, plus 2 PO4 3 minuses, aqueous. And again, I do get the charges from the list of polyatomic ions on these things. So anyways, let me just get rid of that. Okay, so back to what I was doing. Plus 3 coppers. Now, what's the charge on this copper? Well, we have two CLs, and each one's a -1 charge, so this has to be a +2 if you're going to balance that out. Again, that's from a long time of cold chemistry. That's something we've been doing for quite a while. All right, so we're good there. Cu3PO4 plus 6 Li pluses aqueous. Sorry, solid. Plus 6 Cl minuses aqueous. All right, so where are the spectator ions? So the lithiums are here, but they're also here. Those are just spectators. We got 6 chlorines here, 6 chlorines here. Those are just spectators. So just the copper and phosphate will produce copper phosphate. Yeah, that makes sense, right? So we got 2 PO4 3 minuses aqueous plus 3 Cu2 pluses aqueous will produce a Cu3 PO4 2, and that's a solid. This time I did have it I didn't switch the order just to show you that it really does not matter which way you have this thing. And that is the net ionic equation for part C.